Hey everyone, the first video on Phi Shastra which I started with the basic concept in physics, that is position and displacement. This lecture we will deal with position and displacement in 2 and 3 dimension, but with the use of vectors which will point us in the right direction. So here we embark our journey from basic to advanced physics. Position is the location of a body. We know how to represent the position in a one dimension, and that was before we have gone through the vectors. Now we are familiar with vector. Then the position can be represented by using the unit vector and arrow over the head for one dimension. For two dimension, the position of body is represented by using the value from any two direction of x, y and z. For convenience, I am using x and y axis. Consider Mr. Smiley is standing above x-axis at 5 meter and from origin of x-axis he is standing at 6 meters. Then the position can be represented as vector r equals to 6x cap plus 5y cap. Or it will be more sensible if you say 6 meter in x direction and 5 meter in y direction. In a more general way, the position in two dimension is represented this way. Vector r, which is position, equals to position x in x cap and position y in y cap. Similarly, in three dimension, the position is represented as vector r equals to x cap, y cap plus z cap. The displacement is the change of position from final to initial. Here final position is r sub f and initial position is r sub I. Then the final position will be vector r sub f equals to x sub f x cap plus y sub f y cap plus z sub f z cap. Similarly for initial position with I being the suffix. Now when we find the difference change in position, delta vector r equals to vector r sub f minus vector r sub I. And we can write the change in position, the change in x position as delta x, change in y position as delta y, and change in z position as delta z. Now let us understand by an example. Consider a rabbit is moving in x direction as x as the function of time t equals to negative of 0.2 t squared plus 7.5 t plus, and in y direction as the function of time t equals to 0.2 t squared minus 9 t plus 30. Now let us find the rabbit's position at 10 seconds. First of all, let us find the x and y positions at 10 seconds. That way we can tell where the rabbit was on x and y direction. Therefore, we substitute the value of t as 10 seconds in x equation and we will get 70 in x direction. Again, we substitute 10 seconds in y direction and we get negative of 40. Now we represent this into a vector notion of position, and this is how we can visualize diagrammatically. 70 meters in x direction and negative of 40 in y direction. Now let us find the magnitude. We know that the magnitude of vector, therefore we write it in a square root form, and we get the square root of 70 squared plus negative of 40 squared equals to 80.62 meters. This is the net displacement at the net direction the rabbit is moving is theta equals to tan inverse of negative of 40 divided by 70. Thus we get tan inverse of negative of 0.5714. We get the angle as 30 degrees in clockwise. Guys, this problem will be understood if you are familiar with vector mathematical operation, which I have clearly explained in my vector lectures. Check that out to clear your concept.